Hello everyone! In this video we will continue to examine topic 7.3, the structure of matter, and in particular we will begin to examine leptons and their antiparticles, the antilepton. So up to now we have dealt with primarily quarks and the composite particles that can be made of quarks. Recall that quarks are part of the Standard Model and interact according to all four fundamental interactions. They can be composed into what are known as hadrons, and there are two general classes of hadrons, the baryons and the mesons. A second completely different type of particle is known as the leptons. And our favorite lepton is the electron. The electron is a familiar lepton. And leptons, just like quarks, come in 6 flavors. Again, flavor is a technical term there. They are, again, organized into generations by increasing mass and energy. But after that, sort of the similarities sort of end a little bit. So the 6 flavors of electrons are the electron, the muon, and the tau particles, all of which, sort of as a general rule, behave kind of like electrons, except that the muon and the tau are significantly bigger, so they have increased rest mass and energy. And for each electron, muon, or tau particle, there is a corresponding neutrino. There is the electron neutrino, the muon neutrino, and the tau neutrino. So each electron has, each of the sort of 3 main leptons, the electron, the muon, and the tau, has a corresponding neutrino. They are all elementary particles, so they are not made up of anything else, and they are all fermions. But in a completely differently to quarks, they do not interact via the strong force. So leptons are not colored, and they do not interact via the strong interaction in general. They all have integer charge, so they do not have fractional charge. And in particular, the charge of the electron, the muon, and the tau is exactly negative E. So what we consider to be just normal -1 charge. That is the sense, and that's probably responsible for the way in which we sometimes think about the muon and the tau as simply being very heavy electrons. They are characterized by another quantum number. So we've already seen baryon number. But they're characterized by another quantum number known as the lepton number, which is simply +1 for all leptons. And correspondingly, -1 for all antileptons. Notice that for every lepton, there is an antilepton. And in fact, we've already seen them in topic 7.1, or at least a few of them. We have seen that when a normal electron is emitted in beta minus decay, it is accompanied by an anti-electron neutrino, which has finally made an appearance right here. So this is our anti-electron neutrino. As it turns out, there are antiparticles of all of those. Only one of them has a special name. And that is the antiparticle of the electron, which is known as the positron. This sort of satisfies our inherent need for symmetry. I can remember for years being kind of annoyed that electrons were not just negative protons, but here's sort of the fundamental answer to that, which is there is more or less a negative electron known as a positron. It is the antiparticle of the electron, and this is how it's written.